Very good morning. Very good afternoon. In my last video, I have discussed about the IC engines. So about the working principle of two-stroke petrol engine and diesel engine, four-stroke petrol and diesel engine. So along with that, I have explained about the differences between four-stroke petrol engine. In this video, I am discussing about the performance testing of IC engines. So to know the performance of IC engine, some testing should be done. While doing the testing, some parameters should be measured. So what are those parameters? So here they have listed out. So what are those parameters? One is speed, fuel consumption, air consumption, brake power, indicator power, frictional power. So heat going to cooling water, heat going to exhaust gas analysis, smoke density. So these are the parameters have measured to know the specifications of the engine as per the specifications of the manufacturer. So whatever the required formulas to do the evaluating the IC engine's performance as follows. So one is what I mean by indicated mean effective pressure. Indicated mean effective pressure. It is denoted by PM. So here they are given MEP, abbreviation is MEP, it is denoted by PM. So what is the theoretical definition? It says indicated mean effective pressure is defined as the average pressure acting on the piston throughout the power stroke. So when the piston head is moving during power stroke, whatever the average pressure it will be acting on the piston, it is called indicated mean effective pressure. This can be measured with the help of the indicator card. So that is with the help of the indicator card. So it can be calculated by using the following equation. MEP is equals to PM, spring value of the spring used in the indicator, that is S, unit is in bar per meter, into net area of the indicator diagram, area in meter square divided by length of indicator diagram in meter. So mathematical expression PM is equals to S into A divided by L, expressed in terms of bar. The next is brake mean effective pressure. What do you mean by brake mean effective pressure? Brake mean effective pressure means is the average pressure which is imposed on the pistons uniformly from top to bottom of each power stroke would produce the measured brake power output. So this is abbreviated as BMEP, is calculated from the following equation. BP is equals to N into PMB LAN K into 10 by 6. What is N is number of cylinders, PMB is mean brake mean effective pressure, L length of stroke, A area of the cylinder, N speed, K it is the engine constant. So that is 1 by 2 for 4-stroke engine, K is equals to 1 for 2-stroke engine into 10 by 6. So this is about brake mean effective pressure. Next is indicated power. What do you mean by indicated power? Indicated power means whatever the power it is available within the cylinder after complete combustion of the charge. So that power it is called as indicated power. So here you can see the definition. Indicated power is defined as the total power developed inside the engine cylinder due to the combustion of the fuel. It is denoted by IP, it is expressed in kilowatt. So mathematical expression is IP is equals to N into PM LAN K into 10 by 6 kilowatt. So what is a number of cylinders? PM means mean effective pressure, L is stroke length, A area of cylinder, N it is speed of the shaft, K it is engine constant into 10 by 6 expressed in kilowatt. Next, brake power. What do you mean by brake power? So brake, the net power available at the crankshaft of the engine is called brake power. It is denoted by BP and expressed in kilowatt. So it is given by BP is equals to 220 by 60 into 1000, where 2 pi is the circumference of the brake wheel, and it is the speed of the shaft crankshaft. T is the torque producing from the breakdown dynamometer, divided by 60 into 1000 kilowatt. So here, rope brake dynamometer, whatever the torque it is in producing from the dynamometer, to measure that one they will be using rope brake dynamometer. So from this, whatever the torque it is producing, so the formula is T is equals to W minus S into R, expressed in terms of Newton meter. What is the W is adding the load for weighing pan, S is spring balance reading, and in Newton, R it is effective radius measured from the center of pulley to the center of rope. So that is R is equals to diameter of drum plus diameter of rope divided by 2. Next, friction power. What do I mean by friction power? So the difference between indicate power and brake power is called friction power. So here you can see the amount of power lost due to friction of the various moving parts is called friction power. Mathematically, friction power is the difference between indicate power and brake power. It is denoted by FP and expressed in kilowatt. FP is equals to IP minus BP. Next, what is mechanical efficiency? Mechanical efficiency is the ratio of indicate power to brake power. It is called mechanical efficiency. Next is indicated thermal efficiency. Indicated thermal efficiency means it is defined as the ratio of indicated power to the heat supplied by burning the fuel. It is called indicated thermal efficiency. So mathematical expression, it is denoted by eta ITH equals IP divided by MF into CV into 100. Brake thermal efficiency. Brake thermal efficiency is defined as the ratio of brake power to heat supplied by the combustion of the fuel. So that is eta VTH is equals to BP divided by MF into CV into 100. Next, brake specific fuel consumption. So the amount of fuel consumed in kg per hour to the brake power, it is called brake specific fuel consumption. BSF is equals to fuel consumed in kg per hour to the brake power in kilowatt. So the BSF unit is kg per kilowatt hour. Next, volumetric efficiency. What do I mean by volumetric efficiency? It is defined as a ratio actual volume of air admitted through the suction stroke to the volume swept by the piston. It is called volumetric efficiency. That is eta volumetric is equals to actual volume of air injected, that is denoted by V divided by swept volume of piston. It is denoted by Vs into 100. Next, air standard efficiency. Air standard efficiency. Air standard efficiency is defined as the ratio of work done to the heat supplied. So that is eta air equals work done W divided by heat supplied QS into 100. So here I can go through the definition. What they are written: air standard efficiency is defined as the ratio of work done to heat supply. It is a measure of thermal efficiency of IC engine. So by calculating air standard efficiency, we can come to know what is the thermal efficiency of the engine, and is used as a baseline to provide a standard point for evaluating different types of engines against one another. So means mainly this air standard efficiency they'll be used as a baseline to provide a standard point for evaluating different types of engines against one another. So if you take an air standard efficiency as a baseline, we can compare with the other engines. To know the other parameters, the air standard efficiency they'll be used as a baseline. Next, relative efficiency. It is defined as the ratio indicate thermal efficiency to the relative efficiency. So here you can see the definition. Relative efficiency of ice engines is also known as efficiency ratio. It is the ratio of indicated thermal efficiency to the air standard efficiency. That is indicated thermal efficiency ITS divided by eta air into 100. So this is about the performance testing of IC engines. So these are the parameters. It will be essential to know the performance of IC engines as per the specifications of the manufacturer.